Good day to everybody. You have made it to the end of chapter 1, which is not to say that you've made it to the end of the videos, because this section is the most difficult section in the chapter, and there will be 2 to 3 videos in order to be able to teach you all that you need to know here. But let's summarize and say that section 1.7 is about solving both absolute value equations and absolute value inequalities. The former of which we're going to focus on in this video, the latter we'll address in another video. And the goal for this video then is that you will use what's called the algebraic definition of absolute value in order to solve absolute value equations. Let's do it. Now, there are a few fundamental ideas that I need to plant in your head before we actually start solving absolute value equations. One of those is a reminder, and that reminder is about what the definition of absolute value is. Recall that when we're finding the absolute value of a number, that what we're finding is the distance that number is from 0 on a number line. So, for example, I've got a picture here that shows the absolute value of -5 is simply the distance between -5 and 0. And of course, how many units away is -5 from 0? It's 5 units, which is why we say that the absolute value of -5 is 5. All right, absolute value of a number tells you how far away that number is from 0. All right, well, that's good and all, but that's not necessarily all that we need to know when we're solving absolute value equations. There's also an algebraic definition of absolute value. Now, this is going to look complicated, but I'll explain exactly what it is that you're seeing in your screen down here. All right, now, first of all, what I just circled there is what's called a piecewise definition. We've defined this absolute value function, the absolute value of x, differently depending on what the value of x is, whether it's a positive number, whether it's 0, or whether it's a negative number. So it's a piecewise definition because we defined it differently for each piece of the domain of that function, if you will. Now, the point of this algebraic definition is this. If you're taking the absolute value of a quantity that you don't know the value of, then you've got to understand what is the relationship between what you're taking the value of and what the resulting absolute value is. Okay? Now, the first scenario here I said, this top row, tells you that if you take the value of some number x and that number x was positive, then you just get exactly the number that you started with. All right? Now, this is something you're very familiar with. If x was 24, for instance. All right, well, 24 is a positive number, and so the absolute value of 24 is going to be equal to that same number, 24. All right, the second row doesn't need much explaining, I don't think. If you're taking the absolute value of 0, of course, you're going to get 0, so I won't do an example there. But what about if we're taking the absolute value of a negative number? So let's say we're taking the absolute value of -17. Well, we're not going to get -17, are we? We can't say that the absolute value of x is equal to the same thing as x here because the absolute value of a number can't be positive. What we can do is say this, that the absolute value of -17, since -17 is less than 0, would be the opposite of -17, which would give you a positive 17. Does that make sense? So, if you take the absolute value of a positive number, the resulting absolute value is the same as that positive value that you started with. And if you had a negative number and you're taking its absolute value will be the opposite of that negative number. That's the definition, algebraically, of absolute value. Now on to solving absolute value equations. And what I'd like to do very quickly is apply that algebraic definition of absolute value for you. Okay? And so what I want to look at is a situation where you have the absolute value of some number that's equal to a constant. All right, now keep in mind there's 2 possibilities here. This a is a variable, and I'm saying this c is a constant. If, depending on whether a is a positive or negative number, that'll determine the relationship between the values of a and c. Let's suppose that a is a positive number, such as 7. Well, if a was 7, then c would be exactly the same as a, wouldn't it? Because the absolute value of 7 is 7. So, if the absolute value of a is equal to c, one possible value for the value of a is c. All right, it's possible that this value and this value are equal to one another. But on the other hand, what if this value a was a negative number? Well, in that case, we've already seen that a and c would have to be opposites of one another. So for instance, if a was negative 10, c would have to be positive 10, right? Because the absolute value of negative 10 is positive 10. So if you have the absolute value of a is equal to c, a second possibility is that a is equal to the opposite of c. Now, I don't want you saying negative c here. That would be inappropriate and misleading. Say the opposite of c, because that'll set you on the right track. All right, we're going to use that principle that if you have the absolute value of a quantity is equal to unknown quantity is equal to c, then either a and c are equal or a and c are opposites of one another. Let's apply that now. And we're going to apply that to solve these two absolute value equations. Okay, now keep in mind, we're saying the absolute value of some unknown number is 13. Now, there's no reason that this number has to be positive versus negative. We've got to consider all the possibilities, and it really could be either one if its distance from 0 is 13. So, here's how we're going to make our equation. And this one's super simple. I'm going to divide the different possibilities into a case 1, that's what this C is, case 1, and a case 2. There are two different cases. It's if x is a positive number, that's equal to exactly the same thing as this constant over here, so that would mean x equals 13. But it's possible that this unknown quantity is a negative number, and if the unknown quantity is a negative number, then it would be the opposite of what you see over here. It would be negative 13. Easy enough, right? Now let's apply that same principle down here in part B. The only difference is we don't just have an x, we've got an x plus or minus number. It happens to be x plus 8 here. But the same thought process is going to apply. Just pretend this is all one quantity right here, okay? And I'm just saying the absolute value of that quantity equals positive 21. Well, either this is a positive quantity and that quantity equals this number over here, or this quantity is negative and it equals the opposite of this. So we could say there's a case 1 where that quantity x plus 8 is equal to exactly the number that you see. But there's also a case 2 in which this quantity is a negative quantity, and if that quantity is a negative quantity, it's going to be equal to the opposite of 21, or it's going to be equal to negative 21, right? Because if I substitute either positive 21 here or negative 21 here, their absolute values are both 21. So that's where these equations are coming from. Got it? And then once you've labeled your cases, it's easy enough to go ahead and find out what the solutions are. I can say that x is equal to 13 here. I can say that x is equal to negative 29 there. And then just to show you that it works, well, what if we plugged in 13 in the original equation for x? You'd have 13 plus 8 is 21, and the absolute value of 21 is 21, right? And if I plugged in negative 29 for x, negative 29 plus 8 is negative 21, and the absolute value of negative 21 is positive 21. Those are some simple absolute value equations. All right, hope we're on a roll here and you understand what we're doing. All right, at this point you understand the basics for how you're solving an absolute value equation, or at least the theory behind it. Now what I'd like to do is, first of all, I'd like to make the quantity inside the absolute value bars a little more complicated looking. So we're going to say it's in the form ax plus b. And then I'd like to show you the three different possibilities as far as the numbers of solutions and how you know when you would have different numbers of solutions. Now, you might have noticed in those two previous equations there were two solutions for those equations, right? Well, sometimes that happens, sometimes it doesn't. And whether it does or doesn't, for now, depends on whether this value here is positive or whether it's 0 or whether it's negative. Okay, so right now we're going to look at what happens when that value c right there is positive, such as this. All right, well, if that value c is positive, then we're going to work this out exactly the way that we looked at a moment ago. All right, beginning with this thought, we know that this quantity here could be a positive quantity or a negative quantity. All right, and so we want to consider both of those cases. So we'll make our two cases. The first case being that that quantity right there, 2x minus 5, is equal to 6. And in the second case being that quantity 2x minus 5 is equal to the opposite of 6, or negative 6. And then we'll solve both of those equations. Alright, so with the first case, that would give us 2x equals 11, and then x would equal 11 halves. And with the second case, we would get 2x equals negative 1, and so we would get x is equal to negative 1 half. Now, do those both work as solutions? Well, let's see if we can do some mental math here. Always when you're checking solutions, make sure you plug into the absolute value equation, the original equation. Don't plug them into the two cases. Alright, that'll be misleading for you later on. If I plug in 11 halves into the original equation, well, 2 times 11 halves is 11. 11 minus 5 is 6, and the absolute value of 6 is 6, right? If I plug in negative 1 half, 2 times negative 1 half is negative 1. Negative 1 minus 5 is negative 6, and the absolute value of negative 6 is also positive 6. We had two solutions, and anytime you're solving an absolute value equation and this constant over here is positive, you're always going to have two solutions. And in fact, I want to make the note of that. Whenever that constant is positive, you always get two solutions. You always have to worry about the case 1 and the case 2. Alright, another case. What if the absolute value of that unknown quantity is equal to 0? Alright, what if c is equal to 0? Well, you might remember from the algebraic definition of absolute value that anytime you get the absolute value of a quantity is equal to 0, that had to be a 0 right there. In other words, this is kind of a nice scenario for you, because the only way the absolute value here can be 0 is if 7x plus 56 is equal to 0, meaning that you're not going to get two different cases here. This is the only case that you need to consider, which means that you're only going to get one solution. You'll get 7x equals negative 56, and x equals negative 8, and then just double check that real quick. 7 times negative 8 is negative 56. Negative 56 plus 56 is 0. Boom, the absolute value of 0 is 0. We've got our solution. So when that constant c is equal to 0, it yields one solution every time. Now, the final case to consider whenever you're saying an absolute value of some unknown quantity equals a constant is what happens if that constant is 0. Or sorry, not if it's 0, what if it's less than 0? In other words, what if c is negative? Well, I don't even have to do any work to show this to you. We just have to appeal to your common sense. An absolute value represents a distance, doesn't it? And so what this equation right here is telling you is that some distance is equal to negative 4. You see a problem with that? A distance can't be negative, can it? And if a distance can't be negative, then that means when you say the absolute value of some quantity is negative, that it's an impossible thing to solve. There are no solutions, in fact. And so this is the nicest case of all, as I mentioned a moment ago. Anytime 0 is 0, c is less than 0, it's negative, no solutions. And this is what you would write down, in fact, for the answer to this problem, is that there are no solutions. Easy, right? Okay, so what I've done in this video is I've taught you how to solve absolute value equations whenever there's a constant on the opposite side from the absolute value. I'm going to make another video where we're going to say what if there's variables inside of the absolute value and variables on the outside, on the other side of the absolute value as well. That's next. Thanks for your attention here. Practice well. Watch the next video. It's a little bit tougher, but the same basic principles apply. You'll be able to handle it. All right, again, thanks for watching. Bye.